So with that, I think we move on to the last presentation. If you could start sharing your slides, please.
Yes. Can you see my screen?
Yes.
Great. Um, I see a small text box. Yeah.
Can you share it in full presenter mode? So in full screen?
Yes. I'm not sure why it's not. Okay.
Yeah, if that is too complicated, then don't worry, it's fine. I saw a little bit of your screen on top and below, but I think we see enough so that we can see your presentation. So yeah, don't worry too much if it's too complicated. Okay, but can you go to the to the beginning?
Yeah.
So that I can introduce you properly. Perfect.
Yes.
All right, thank you so much. Okay, so we will hear from Team Iguana Colossus Bogle Agitato. And I'm gonna ask you later how you came up with that name, about the impact on ENSO on climate variables in the Pacific region. And can you go to the next slide so that I can introduce you guys? Thank you so much. The mentor was Tejas Dataramore, is that correct?
Yes.
Yeah, okay. And then we have several members of the team. We have Anjana Sri RJ, Kimia Marvi, Kirtana Sunil Patnani, Neil Mark Sordillo, Eligio Maure, and Danny McCulloch. Please start with your presentation.
Thank you so much. So thank you everyone for this opportunity. I'm very excited to take you through what we have worked on, and especially because what we have is a combination of like a lot of diverse perspective. As you can see, we have people from India, we have people from Philippines, Neil is from Philippines, Kimia is from Iran, Anjana is from India, Aliju is from Japan, and Danny is from UK, and Tejas is from India. So what we did as a part of Climatematch was we came along with a lot of different perspectives in the way. And what we discussed was that Neil is from Philippines, and so he told us that every year Philippines experiences like 20 typhoons, and it gets worse with the El Nino effects and the ENSO effects. So it was really, we were really curious to see what really happens because of ENSO on the Pacific region. So we started with a small region in the Philippines. And so essentially, as we have described earlier, is present in the Pacific Central regions. It's characterized by the sea surface temperature anomalies in the Nino 3.4 region. And when the sea surface temperatures are greater than 0.5 degrees Celsius, we call it El Nino. And when it's lesser, we call it La Nina. And what we also see is that our ocean has a regulation of sea surface temperatures where the warm waters get cooled down by the polar regions. In this context, the ENSO comes about as phases that exist as a coupled phenomena between the atmosphere and the ocean. And over here, what's important to see is that with the anthropogenic factors that we have, where we are increasing the greenhouse gases that we release into the earth, we have increased the frequency of ENSO. And with this increase in frequency of ENSO, we have more unprecedented events and also temperature extremities. And for regions which are like even not developed in terms of infrastructure, especially like the Philippines and other regions, it becomes important to analyze what will happen there and how to prepare for that. So the data sets we used was the ERSST data set from NOAA for the ONI anomaly index. For the precipitation, we use CMAP data set. For the air temperature, we use the GISS data set, which is by the NASA. And for the cloud coverage, we use the CMIP 6 data set. Now, we began in our project to understand what really happens in the precipitation when we look at Philippines region. And what we did was we plotted a correlation map between the ENSO index and the precipitation anomaly. And we found that the precipitation was negatively correlated with the ENSO index, which means that as the temperatures were rising in the sea surface, the precipitation was falling. So in El Nino, there was a drought in Philippines, whereas in La Nina there was a flood in Philippines. So as we began this program of expanding our research, we looked at a couple of variables which were like precipitation, sea surface temperature, and air temperature. And from our study of existing what happens in the Philippines, we wanted to understand what happens in the countries that are surrounded by the Pacific Ocean, specifically in the western side. Next, we wanted to understand because the ENSO is impacting the countries and overall the water circulation, how is it really impacting the sea surface temperature in the polar regions? Um, and thirdly, we wanted to understand what is the impact of ENSO closing the entire loop in the Pacific. So we wanted to understand this entire cycle. So to begin with, we plotted the precipitation and ONI correlation. And what we find here is in the western countries of the Pacific, there's a negative correlation as compared to the sea surface temperatures in the on the ONI index, which means that as temperatures rise, similar to what happens in the Philippines, as temperatures rise, there is drought, and as temperatures fall, there is floods. Another parameters that we analyzed were sea surface temperatures in these regions as well as the air temperatures. And firstly, what we see that these two graphs look very similar, which means that both of these parameters, such as the sea surface temperature and the air temperature, are closely interrelated. Our second observation was that the sea surface temperature is mostly correlating with the global temperatures positively. So we see a lot of density of red as compared to blue. And thirdly, our observation was similar to that about the precipitation, that in the C-shaped region, there was a negative correlation that happened. We can observe and conclude that in El Nino, we end up with a lot of droughts in the Western Pacific countries, and in La Nina, we end up with a lot of floods. And overall, monitoring these tendencies in the phases of ENSO becomes important because we have to understand when is this drought happening, when are floods happening, because overall they lead into a huge impact for the GDP of the country as well as cost of lives for the country. So our key takeaways are precipitation is positively correlated with only in the central Pacific region during El Nino, but negatively correlated with the C-shaped region covering Southeast Asia and Australia. The sea surface temperature and air temperature was also positively correlated with only globally, which means that as we see an increase in the El Nino temperatures, we are going to experience much more heat, which is already happening now, and we have already received a warning this year. And we also find that the ENSO is significantly influencing regional climate changes and economics through its effect on agriculture, disasters, and health. In our future scope of the study, we understand that not only ENSO affects the climate temperature, but there are other oscillations that occur in the ocean that may affect what really happens in the climate. So we want to expand our scope from only studying the ENSO to Atlantic multi-decadal oscillation and the Indian dipole ocean. Another area we want to take this to is anticipating the potential future changes in ENSO behavior and its implication in the global climate change. So, as a part of our proposal, we actually wanted to construct this model, but because of the overall size of the data that we have to process, we were not exactly able to do that. But given the intensity of change it can help bring about and really, help people, it is very crucial to do that. Yeah, these are some references. Yeah, that's all from me. Thank you so much. I have Eligio and Kenya here.
Abigail, do you want to ask the first question?
Unless someone else wants to first. Okay, I can
No,
start.
go ahead. Yeah.
Would you mind sharing your screen again?
Sure.
And could you go back and stop, please? So I'm wondering if you've had any thoughts, kind of your research questions, which are really big and important, kind of touched on the dynamical relationship between the different like geographical locations that surround ENSO. And I'm wondering if you've had any thoughts on how these results or these plots relate to some of the questions you were interested in. And I forget if you said something about the data, but if you looked at maybe trends like the other group, if you might learn something about the regional correlation of all of this.
Right. So if I understood correctly, it was understanding how specific regions had differences. So basically, about the questions in the first and how we came to this and how they were correlated. So what we were able to do was plot correlations. But if we were to really understand what is happening in the cycle, I think this would make more sense because this is sort of a consequential sort of a study which shows that from here it went to this, like right over time how the ocean currents are flowing and such things. So I think that right now we've done like a over time analysis. But if you were to do like a more causal analysis in the sense that what happens in each of like these cycles and what leads to what, then it will be much easier to get to exactly what how is the ENSO getting much more leading to much higher ranges every year, every consequent year.
Yeah, that makes sense. And could you share a little bit about the data that you used for this? I'm sorry if I missed it.
Yeah, no worries. Yeah, so we used mostly observation data, which is reconstructed. And here we have the sea surface temperature, and it's from 1984 onwards to 2024. So all till the recent times, and we have this data for so 1984 was our lower limit because that's the least we had, and then rest all we had in that data range. So we had all these data sets used.
Great. Thank you
Okay,
so much. Yeah, someone else.
Birgit, I'm gonna take the prerogative since they're on this slide to jump ahead. The one that you didn't show was cloud cover. As far as I missed, unless I missed something, we never saw any results related to cloud cover. So I wanted to ask what question you had that was motivated, that motivated you to gather cloud cover data. That's the first question. And the second question is if you anticipated any challenges in taking a set of observations made in the real world, from these first, which are based on observations, and comparing them to predictions from a climate model. So maybe those are two questions. What had you hoped for from the cloud coverage that maybe you didn't get to? And then how hard is it to make a comparison of observations and a model prediction?
Yeah. So what we tried to do with cloud, so we were essentially asking the very big questions about what causes ENSO and how can we model that and what is increasing over time, maybe the anthropogenic factors. So Danny is studying clouds, so we got like a little bit information about that from there. So he was telling us that how when ENSO happens, there's like the whole Walker circulation and the density of clouds changes in the region. So in the tropical regions, the clouds may be fatter in terms of like length. As we go towards the polar, they become thin and but more coverage. That was the idea behind going behind cloud coverage and understanding it from there. We also tried to process ocean currents data, but we had a lot of NaN values, so we couldn't get like conclusive results out of that. But yeah, we were essentially trying to figure out the causal cycle of ENSO, so that we can better understand where is the heat coming from, how much, quantify how much is the change.
Just for context, it's a really good question. It's pretty hard. People have been working on this
Yeah.
for a while, so
Yeah.
that you didn't get to figure that out in a few months is not a huge surprise. Birgit, you had a question.
Second,
Yes. I
yeah.
actually wanted to ask exactly about the cloud coverage as well, because I didn't see it on the results. But I have another question as well, which is on your last slide, concerning your last slide. You mentioned that it would be great if you could predict ENSO into the future. I think you are right, that would be great. But I think it's super hard because this is not a cycle that comes and goes in a regular pattern, right?
Yeah.
Did you have any ideas on how you would want to tackle that, or is that just the idea that you think that would be a great thing to do in the future?
So while studying the literature, what I found was that in local, so I assume that where for the like regions which have like if we focus on a particular region, right, then it's kind of easier to have a time series prediction because it becomes statistical, but we don't really know like external parameters. So if we really simplify everything, but what I found was that in regions of countries which are not so developed, the data is even less. So when the data is less, it becomes really hard to predict. So what I was thinking is overall, because climate change is happening globally, we really need all these systems in place because they're going to get affected whether they're rich or poor. So, and once they have the systems in place, so I don't come from an environmental science background. I don't know how much that takes, like how to install the systems and everything. But I think once they have certain systems in place, it would become much easier than now where there is no data or there is less data.
Yes, definitely true. Thank you. Yeah. Can I ask one more question, Robert?
Yes, although let's also leave room for Natalie.
Yeah, that's a very quick question.
Go ahead.
Okay, I just want to come back to the name of your team. How did you come up with the name of the
Yes.
team?
So the answer is we didn't. And in Climatematch, we were assigned this name by Climatematch. So essentially, it is a dinosaur's name mixed with a dance type. So Iguana Colossus Google is a dinosaur, and Agitato would be a dance form. And
Okay,
we
thanks.
stuck with that. Like I think that I really love my pod. like we have done. I'm really happy to be on this team, and yeah, it was great
Cool.
being a part of this.
All right, thank you. Yeah.
Natalie, you had a question.
I'm a little mad at myself for even asking a question because that was such a good end to the presentation and your positive note on how much you like your pod. Um, I think that might be a little out of your scope even, but do you know if there are or what kinds of preparations are going on once countries can predict to a degree whether it's going to be a wet or dry year?
So because Neil was from Philippines, they have an indicator in Philippines which tells them whether it's going to be an ENSO year, and in preparation they prepare the agriculture. Um, in then another like I took a look at India as well, and what I found was in India they might be able to predict it, but consequently, apart from prediction, there has to be a whole infrastructure set up by the government or by whoever the private authority is to actually take care of the floods. Because what happens in India is that um, um, there is like people make infrastructure, but it's not in certain regions, not in everywhere, but in certain regions they make infrastructure, but it's not strong enough to bear the floods that come in. So it gets destroyed every time. So part of the prediction is the prediction, but like also we have to cater to preparing for the floods, for the warning signals, so that our infrastructure is ready for this. And I think I feel really bad that climate change is happening. So I feel we need to do it all now, really fast.
Thank you.
Okay. With that, I would draw the presentations to a close. Abigail, I would hand it back to you. Thank you very much. That's a pretty interesting set of presentations.